The equations in the Solve It demonstrate an important relationship in right triangles called the Pythagorean Theorem. This theorem is named for Pythagoras, a Greek mathematician who lived in the 500s BC. We now know that the Babylonians, Egyptians, and Chinese were aware of this relationship before its discovery by Pythagoras. There are many proofs of the Pythagorean theorem. You will see one proof in this lesson and others later in the book. The Pythagorean Theorem, Theorem 8.1. It states, if a triangle is a right triangle, then the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So if, in the diagram, ABC is a right triangle, then leg 1 squared plus leg 2 squared equals the hypotenuse squared, or A squared plus B squared equals C squared. A Pythagorean triple is a set of non-zero whole numbers, a, b, and c, that satisfy the equation a squared plus b squared equals c squared. Below are some common Pythagorean triples. Note that 3 squared plus 4 squared equals 5 squared. 5 squared plus 12 squared equals 13 squared, and so on. If you multiply each number in a Pythagorean triple by the same whole number, the three numbers that result also form a Pythagorean triple. For example, the Pythagorean triples 6, 8, 10, and 9, 12, 15 each result from multiplying the numbers in the triple 3, 4, 5 by a whole number. Problem 1. Finding the length of the hypotenuse. What is the length of the hypotenuse of triangle ABC? Do the side lengths of triangle ABC form a Pythagorean triple? Explain. Well, we know the Pythagorean theorem, which states that the sum of the squares of the lengths of the legs of a right triangle will equal the square of the length of the hypotenuse of that right triangle. So we can state it more simply as the equation a squared plus b squared equals c squared, and substitute the values given, the leg lengths, 21 squared plus 20 squared equals c squared. We'll let c stand in for our hypotenuse length. 441 plus 440 equals c squared. 841 equals c squared. And applying the square root to each side of the equation, we find that c equals 29. The length of the hypotenuse is 29. The side lengths 20, 21, and 29 form a Pythagorean triple because they are whole numbers that satisfy the equation a squared plus b squared equals c squared. Your turn. Part A. The legs of a right triangle have lengths 10 and 24. What is the length of the hypotenuse? And Part B. Do the side lengths in Part A form a Pythagorean triple? Explain.